Hello. In this video, we're going to begin our study of what are called permutations and combinations. Now, those might sound like some big fancy words, but the basic idea here is pretty simple. We want to look at all the different ways of counting things. How can you count how many outfits, or count how many digits, count how many passwords? We want to look at the ways you can count. And so let's look at a very, very simple example. How many different two-digit numbers can be made by using the digits 1 to 5. You may repeat digits. So we have the numbers 1, 2, 3, 4, 5, and we're making a two-digit number. Now the easiest way to do this is to start writing them out. You can make 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Then you could make 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. And finally 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. So if we look here, we have a total of 25. And so our answer would be 25 numbers, 25 ways. The number of different options we have that we could make with all of these digits is 25. And I mean, that works pretty good, right? We would write them all out. It's nice to see the picture here. But imagine if instead of making two-digit numbers, we were making maybe three-digit. Or, if you have a password on your phone, it might be a six-digit passcode. Imagine if you didn't have just the numbers 1 to 5, if you had all the digits 0 to 9. You could imagine that the number of options here is going to get quite large. It's going to be more than 25 or 30. It might be in the hundreds or the thousands, maybe even in the millions. And so we're going to need a better way of discovering the number of options than just writing everything out. Again, writing everything out is a good strategy to start because it gives us a concrete idea of what we're looking at. But we really want a general formula. We want some kind of method, some kind of tool to do this counting for us. Now, if you look here at our diagram, we sort of have 5 columns and 5 rows. And it looks like we could do 5 times 5 as a shortcut. Maybe you've seen that already. You're thinking, oh yeah, there's like 5 groups and there's 5 in each group. 5 times 5, that gives us 25. So maybe we can use multiplication as some kind of shortcut. Let's look at a more advanced problem here. How many different 4-digit lock codes can be made using all 10 digits? And you may repeat digits. So this is like if on your phone you have a 4-digit code, you can use all 10 digits. Remember, we have the numbers 0 through 9. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's a total of 10 digits, 0 through 9. And we're thinking about our code. So it's almost like we have our code we're typing in, right? Maybe the code is 3215, or maybe the code is 6700. How many different codes do we have? And really quickly we can see, man, writing them all out, that's going to take a long time. I don't know if I want to do that. But multiplication does seem like a pretty good idea. We have 10 different options for that first digit, right? We could use 0 through 9. Then we have another 10 options for the second digit, because again, you can reuse digits. Your code could be 0000, right? There's no problem reusing digits. You could have 0 through 9 again and 0 through 9 again. So each digit, your first, second, third, and fourth digit, has 10 options. And just like in the last example, we multiplied our options. So 10 times 10 times 10 times 10 gives us 10,000. And that is indeed the number of ways we could do this. We have 10,000 different combinations, different codes that we could use for our phone. And the way we come up with that is by finding the amount for each digit and then multiplying them together. This is sometimes called like the multiplication method or even the multiplication principle. And what I like to do is draw these blanks that represent each digit in the code. It helps visually organize it for me. And yeah, it seems to work. But let's see how we can apply this to something a little bit more abstract. We have a restaurant that offers 4 sizes of pizza, 2 types of crust, and 8 toppings. How many possible combinations of pizza with 1 topping are there? All right, so again, let's try to start writing this out. But before we come up with a formula, let's get our heads around the problem. We have 4 sizes of pizza, right? So for our sizes, we're probably thinking small, medium, large, and extra large. For the 2 types of crust, we're probably talking thin crust and thick crust. I guess this restaurant doesn't have stuffed crust, but that's okay. We've got 2 options, some tasty pizza. And then for our toppings, we have 8 different toppings. So maybe we have pepperoni, maybe we have mushroom, maybe onion, maybe pineapple for people who like to put pineapple on a pizza. I know that's a whole debate. We're going to ignore that for right now, but we've got 8 different toppings here. Now, we're only allowed to put 1 topping on the pizza. It's just a 1-topping pizza. And we're trying to think, okay, how many different pizzas could I order here? What kind of options, what kind of combinations do I have? Well, I'm going to draw the blanks like before. We have a blank here for the size. Because if you're on the phone, they're going to say, what size pizza would you like? That's the first question you have to answer. Then we're going to have a blank for the type of crust, because they're going to ask you, would you like thick or thin crust? Then we have a blank for the topping. They're going to say, which topping do you want? Do you want pepperoni, mushroom, onion, pineapple, whatever other toppings you might have, chicken, beef, maybe peppers or tomatoes. You get to pick one of 4 sizes. So there are 4 choices for the size. You get to pick 2 types of crust, right? Either thick or thin. And you get to select from 8 toppings. Now, these numbers, just like when we did the 5 times 5, we have to multiply these numbers. 4 sizes times 2 types of crust times 8 toppings. So 4 times 2 times 8 is going to give you 64 pizzas. And so there are 64 different pizzas you could order from this restaurant based on the sizes, the crusts, and the toppings. Right? So one pizza might be a small, thick crust pepperoni. One might be an extra large, thin crust mushroom. And you could write out all 64, but the formula allows us to come up with that answer of 64 much quicker than we could write them all out. All right, I encourage you to pause the video here and give this question a try. See what you come up with. Okay, so hopefully you gave it a try. You're getting dressed in the morning and you have 5 shirts, 3 pants, 10 shoes, and 2 hats. How many outfits are possible? Now, I guess maybe I should have been a little clearer here. Is it 10 shoes or 10 pairs of shoes? Let's say it's 10 pairs of shoes. So let's go ahead and draw our blanks. Sometimes this can be called the blank method. You have the blank for the shirts. You have the blank for the pants, the blank for the shoes, and the blank for the hats. Now we're assuming that you're wearing each item of clothing. You're going to wear a shirt, pants, shoes, and hats. How many options do I have for each one? There's 5 shirts. There's 3 pants, there's 10 shoes, and 2 hats. Multiply them all together, and we're going to get 300 outfits. Again, with a number like 300, you would never want to write out all the different combinations. It would be way too many. But using the formula, we can get the answer pretty quickly. So we're going to go ahead and take some notes. It's nice to summarize what we did and have some notes, just that way you can refer to what we were learning later. So I'm going to call this the fundamental counting principle. The fundamental counting principle. Okay. And here in this first quadrant of our notes, we're just going to write down basically what we did. We'll write down some information about what we learned. And we learned that if there are n ways of doing something, and m ways of doing something else, then there are n times m ways of doing both actions. Okay, now sometimes when we have more general notes like this, it's nice to give a concrete example. So over in this quadrant, we're going to do an example here. So let's say we flip a coin and we roll a die. A die we're going to assume has 6 sides. 6 sides. How many different possible outcomes are there? So go ahead and pause the video and see if you can solve that problem. All right, so using again the blank method, we flip the coin and then we roll the die. A coin has 2 sides, heads or tails, so there's 2 options there. A die has 6 sides, so there's 6 options there. We multiply the 2 of them and we get 12. Now, for a number like this, we could write out all the different options, right? We could either get a heads and a 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1, tails and 2, tails and 3, tails 4, tails 5, and tails 6. So we could write out all 12 options if we wanted to for a question like this. But as, of course, you see the numbers get bigger, we need this general formula or general method so that we don't have to write them all out when we have 100 or 300 or 1,000 different options. Now here in the next quadrant of your notes, I want you to try an example. And so here we have Unit 1, Worksheet 1. So you can try an example from there, or if you want, you can go online and look at Worksheet 1.5, which has some further examples, Worksheet 1.5. Both of these give us some more examples of what we were working on. And so I want you to, in your notes, pick one of those examples, pick an easy one, pick a hard one, pick maybe a strange looking one, and go ahead and try that one yourself so you have some notes on how to do it. Again, picking an example that is interesting to you. Then in the last quadrant of the notes, I call it TTR, things to remember. Down here, it's nice to remind ourselves of, any interesting ideas, anything that didn't make it into the rest of the notes that we know we're going to remember for later. One thing that always trips me up is that 0 to 9 is 10 digits. I always think, 0 to 9 is like 9 numbers. But I'm like, oh no, you got to count the 0. So 0 to 9 has a total of 10 digits. That might be worth writing down in case you forget that. So that about does it for our first video. We're going to continue looking at ways of counting for a lot of different techniques. And we'll learn a lot of tools and a lot of shortcuts and formulas. But at the end of the day, it all boils down to this question. We have some kind of situation, and we're trying to count all the different options. We could write them all out, but we also want to find formulas that allow us to do that faster, more efficiently, shortcuts, if you will. Hopefully you enjoyed this video, and as always, thanks for watching.